If you are going to study the calculus or anything in mathematics, it is important to know where it came from, and math very much has a history to it. The origins of the calculus are very steeped in controversy. Most credit Isaac Newton with its discovery. We all know the story of Newton and the apple tree. Newton invented the calculus as the mathematics needed for his work in physics, gravitational force, etc. His first writings on the calculus can be traced to the year 1666, developed from the work of his own teacher, Isaac Barrow. The notation Newton developed was very cumbersome and has not survived the test of time. Newton published his discovery of the calculus in 1686 in his work Principia Mathematica. Controversy arose through the works of Gottfried von Leibniz, a man brilliant in every subject. At age 8, he taught himself Latin and then moved on to Greek when he got bored. By age 20, Leibniz had completed all necessary work for a law degree, but the University of Leipzig refused to confer the degree due to his young age. Leibniz did not really begin to seriously study math then until the age of about 26. He invented the first multifunction calculator, one that added, subtracted, multiplied, divided, and found roots of numbers. In his study of mathematics, Leibniz was very conscientious of efficient and proper use of mathematical notation. He is the one to have coined the coordinate geometry terms abscissa, ordinate, and coordinate, as well as the name transcendental functions to refer to non-algebraic functions. The issue with the controversy is whether or not Leibniz discovered the calculus independent of Newton, or if he simply invented a different notation for the calculus after deriving its fundamentals from Newton's works. Leibniz claimed he invented the calculus after studying the works of Blaise Pascal, and his works can be dated back to the early 1670s. Leibniz created the notations dy and dx to denote infinitely smaller differences between neighboring y and x values. The derivation of the derivative with the secant line approaching the line tangent to a curve at a specific point, that can be credited to Leibniz. It is he who noted that the area under a curve could be found with a summation of infinitely many thin rectangles, an idea later formalized by Georg Riemann. Emphasizing the inverse relationship between two processes, it was Leibniz who named them differential calculus and integral calculus. Leibniz published his own discovery of the calculus in 1684, 2 years before Newton did. The work included the power, product, and quotient rules for finding derivatives, methods of finding maximum and minimum points of a function, and a statement of the fundamental theorem of calculus. And perhaps the best testament to Leibniz's work, it is his notation that we continue to use today. The controversy then over the discovery of the calculus began to brew in the 1690s as it was gaining popularity among European mathematicians and being attributed mostly to Leibniz. Pointing to the fact that Newton's work could be traced to 1666, all of England rallied behind Newton, claiming that Leibniz had somehow stolen Newton's ideas, while all of Germany rallied behind Leibniz. Thus began a century of national animosity, accusations, and suspicions. Studies of Leibniz papers and the likely dates of his writings indicate that extraction from Newton's manuscripts could have been possible. Shortly before his death, Leibniz admitted that in 1676 he did come in contact with some of Newton's works, but he implied they were of little or no value. Today it is accepted that Newton and Leibniz both discovered the calculus, simultaneously but independently of one another.